Hello everyone and welcome back at CodingBulls. Today we will solve a problem where you will need to use all of our 4 previous beginner C++ tutorial videos in order to solve it. If you haven't watched them already, make sure to watch them before you continue with this episode. If you have, let's go ahead and open up CodeBooks. As you can see, I already prepared a problem for us that we can read and solve. So this format of the problem is similar to the format that you will see in competitive programming. First, we have a description of the task, which is that we have an n times m chessboard with a piece on the top left corner. We can only move it right or down, and we need to reach the bottom right corner. And we also need to do it with as little cost as possible. The cost is defined with every cell having its own cost, and it gets added up if we step on it. And we have 2 sub-problems. The A is that we need to find the minimum cost possible, and the B is that we need to output any sequence of moves that reaches the bottom right corner with this minimum cost. First, let's take at the input. We will have a line that contains the size of the chessboard, 2 integers, n and m. And as we can see, the limits of n and m is that they are at least 2, but at most 1000. And each of the next n lines contains m integers. That means that we will have n lines, and in each line we have m integers, so n times m integers total, and each of these numbers will be referred as a cost of that cell, cost ej, with at least negative 100,000 and at most 100,000. And we need to output for the A problem a single number, the minimum cost possible. For the B problem, output a sequence of characters with letter capital R, meaning that we go on the right, capital D, meaning that we go down. And it has to be the minimum cost possible. If there are more solutions, then we are free to output any of them. You can go ahead, pause the video and try to come up with a solution on your own, or you can continue watching and see the solution. Hopefully you have time to figure it out. If you want to just see the solution, we can start coding. First, you can see that I removed all the usual codes. That's because it's a good thing to practice writing them down sometimes, so you don't forget these basic lines. So first thing that we need to do is include a library, and as I explained in the previous videos, one of the best libraries to include is the bits for stdc++.h, because it contains so many other libraries and you don't need to worry about including other libraries as well. Then we will be using namespace std, because lots of times we use std functions and we don't want to type out std prefix every time. And we will have the main function, and we will have the n and m variables, and we will take them on the input. The reason I'm taking the n and m as a global variable is because probably during the solutions I want to refer them somewhere else in the code, maybe in a function, so it's more comfortable having them outside in the global function. So first we will take the input, the first line, the size of the chessboard, n and m. So we go ahead and take it from the input, done. Now let's take a look at the next line of the input. We will have n lines containing m integers, the cost of the cell. So we obviously want to read this input and store this value. For this, we will take a look at the cost of the cell. You can see that it's between minus 100,000 and 100,000, meaning that it's comfortable to use an integer. And reminder, an integer has 32 bits, so it can have the maximum value of 2 to the power of 31. And in case of unsigned, the maximum value 2 to the power of 32. This is the max value, which you can also refer to it, this first max value, as int max. And this is also a bit more than 2 times 10 to the power of 9. This is a good estimate that you should remember, because in most programming, competitive programming, there are constraints which is roughly about 10 to the power of 9. So in the problem statements, they like to give the maximum value in a power of 10. So you can estimate that this is roughly about 2 times 10 to the power of 9. So if it's something more than that, then you will need a long integer. And as a reminder, long integers has a maximum value of 2 to the power of 63. Unsigned has 2 to the power of 64. This is the maximum value, and of course minus 1 in this case is, and minus 1 here as well. So this is the maximum value that you can use. So for the cost we can use integer. If you don't want to worry about it, it's also always just double the size. You can see that it has 64 bits, while the integer has 32. So you can also use long integer every time. It will double the memory, but it's not that big of an issue if you are not close to the memory limit. So we will use integers this time. And we will have the cost, which I will make a 2-dimensional array, named C, and I will have a const integer capital N, which will be equal to the maximum size of this, which is 1000, and I always like to add 1001, so we have the 1000 index as well. As you can see, we have two variables named n, but this is a lowercase n and this is a capital N. And in C++, they are different variables, so you can use different capital or lowercase characters, and they will be different variables. So we create this array. In the last video, I used array and vector as well, in a 2-dimensional vector array. I will use an array in this example. You can also use vector the same way I did in the last video. So we will do a nested for loop, also from the last video. Hopefully you are comfortable with using this to get the input. Something that you should always double check is that you have the correct values here. So we go from 0 until n in the outside loop because we have n lines. So the outside loop will be 4 lines and the inside loop will be 4 columns. And we go from 0 to m. And it's a really good thing to double check that you make a ++e here and a ++g here, because it's technically correct to use another variable, another expression. So ++e is correct, it will compile, but of course it will be an infinite loop because we initialize g as 0, and it will remain 0 because we don't upgrade g's value in this statement. You can also output other statements here as well. So g plus equals 2 is also correct if you want to go through every second number in the for loop, and you can even give another expression if you want. But for loops it's most common to use ++ and the character after. So we will have this nested for loop, and in this for loop we will take from the input the cost of the e, a, j value, cost of the I, j value, and we can take it from the input, and we don't have to do anything with it. For the moment, we will just go ahead, run these loops, and take it from the input. So this is how you should start every problem. Take everything from the input and store it in a type of variable that is comfortable for you. You can see that we haven't actually started solving the problem, but we already have a code. This is a very good solution for any kind of problem. Even if you don't have idea, just start taking from the input in the way that's described in the statement, and you will have everything stored with these variables, which is most comfortable for you and you would like to use it. And now we have these variables, and now we can start thinking of a solution. So what we know is that we are on the top left corner. If we go ahead and draw both here first, most of the time you want to use a pen or pencil and paper to draw these, or you can just do it on here in the comments. I will show you in the comments so you can follow with me. So we have numbers, let's say, and you can see that negative numbers are out in this statement. So as you can see, we have these numbers. I will put them in the same line so you can see better. Yeah, it's visible. So we start here and we want to reach this. So even if you don't know the solution right now, what you need to do is to create some sort of plan. Let's say that we want the cost of it as a function. So we will create a function and we will take where we are right now, because this will change when we go through the different numbers and different cells. So we will have an x coordinate and a y coordinate, our current position. Now we know that the answer to our problem will be equal to the cost of 0, 0, because we start on the top left corner. And as you can see, we haven't actually write the code for the cost function, but we can use it in our code. That helps you think about the solution, that if I have this function which can do this, then what is the solution? And if I already have this function, then I can just solve it like this. And one more thing you need to pay attention is that these numbers, 100,000, negative 100,000, between 100,000, they are inside of the integer limit. But you need to check if they are actually inside the integer limit if you add them up. So you need to estimate the most it can be and see if it's inside of the integer limit. So what happens when we go through this table? We can actually go to the problem statement. And here, when we need a sequence of characters, we actually know how long it will be. It will be n plus m minus 2 characters long. And the reason for this is every time you will go right, down, so you need to go n minus 1 times right, because you start here and you need to go to the right edge, and you will go n minus 1 times down, because you are upside and you need to get down. The order of it can change, but the length will be the same. Actually, we will have n minus 1 right steps and n minus 1 down steps, so it's fixed too. So in this case, we can estimate the maximum value. n plus 1, m minus 2 is maximum 2000 minus 2, which is 1998, and we count with an upper bound, which is 2000. We want to estimate the maximum value, so we can add some numbers, but we can't subtract. So 2000 times, which is the maximum, 100,000, which is 10 to the power of 5. So 10 to the power of 5 times 10 to the power of 3 times 2, which is 10 to the power of 8 times 2, which is inside our integer limit, so we can use integer for the cost. Now let's say that I say that the cost is 10 to the power of 9, 10 to the power of 9. In this case, so our cost can fit inside the integer type, but when we add them up and have the answer, then it can no longer fit inside. So I will go ahead and pretend that like this is the original problem statement. Now I will type code typedef long int SL. So now I will change this function's return value to long and the answer is long. Then I will go ahead and make this answer global variable, because maybe in the other subtask we want to use the answer outside of the main function. So we set our answer to this cost. Now we actually haven't write this code yet, so let's go ahead and do it. So if we stand somewhere, how can we define the cost? Well, we don't know yet, but what do we know? If we stand here, well then the cost will be very simple. And as we can see, which is this coordinate is n-1 and y coordinate is n-1. So if it's that, then we will return simply the cost there. -1 and -1. So if we are there, we know the answer. But if we are not there, well, then we can go left, we can go right or down. But we can only go right if we are not in the right side of the board. If x is not equal n-1, or which is easier to see, if x is less than n-1, this is the same because x can't be more or equal to n, because it has to be inside 0 and n-1, and y can be more than n-1. So both of these codes are correct. I will use this one. Then we can go right. And if y is less than n-1, then we can go down. So what do we do if we can go right? Well, then we will have a possible solution from here, because let's say we are here. So the optimal solution will be either to go to the right or go down. We don't know which one, but we know one of these will be the solution. So we will solve from the problem from here and from here, and we will choose the solution which has the lower cost, because that will be the correct. Of course, we don't know the solution from here yet, so we will use what's called recursive functions that you could see in our third lesson. So we will refer to this, so we can go right. So we will have a new cost if we go right be equal to, and of course first we need to add the cost of this current position because we already stepped on it. So cx y plus the solution, which is the cost function of x plus 1 y. So we can add this up, and this is our right cost. But if we go down, then we will have a new cost down be equal to the cxy also plus the cost of x y plus 1, and we go down. So to demonstrate this new cost right from this position will be that we go right and then we solve the problem from here. And the new cost down will be that we are here, we go down here, and we solve the problem from here. So now we have both of these costs, and we need the lower one, and we will return with that. Now there is a problem. We define these variables inside of the inflow. So if we want to do something that, let's say, if this value is less than this value, this will be a weird error. The reason for this is these local variables are only live and can be referred to inside of these blocks where they were defined. So if you define them here, you can't refer them outside of this scope. So you can see that it was not declared in this scope. So it was declared, but not in this scope. It's not a variable here. What we can do is declare them outside of these if blocks. And we will also need to give a default value for them. Because if we don't go into the if function, then we can't go there. So let's say that we define them for 0. This is wrong, because if we are right here, we cannot go right, so this will new cost right will be 0. But when we reach this code, we will simply skip this, because x is not less than n-1, it is n-1. So we don't update the new cost right value, and therefore it will remain 0. And when we add the new cost down value here, it will be -2 plus 3 plus 11, which will be 12. So it will be higher than our new cost right. So our program must firstly think that going to the right is the correct solution because it's lower. And actually it's not even possible. So for that to work, we need to initialize it with a value. But we need a higher value than the highest possible value. Or we can have a Boolean value where we store if it is possible to go there. I will go ahead and show both of the solutions, and then you can use whichever is more comfortable for you. So we will have this int maximum here, but this is actually not enough for us, because as you can see, the int max is the maximum value of integers, and this cost of the cells, if you summarize up, it can be larger than that. So what we can do, I usually like to do, is just multiply by it again, because this is the 32-bit maximum. And then, if you multiply it by itself, it will be the 64-bit maximum. So you can just go ahead and do that. Now, whatever happens, we will go into one of these if statements. Because if we wouldn't, then it means that x is n-1 and y is n-1. But in that case, we already return here. So it will go ahead in one of them. And that line will be definitely lower than the other, so we don't have to worry about it. So this is one of the solutions. In my opinion, this is the easier one, but you do need to think about the maximum value. The other solution is that we keep it 0, and we have Boolean variable if we can go right, which is false as default, and we have a can go down. And then we will update this if we go into the if statement. So in this example, we can see if we can go down and if we can go up. In this case, we do need to check after the if statements. So if we can, this means that the next statement is false. So if we can go right, so if can go right is not true. So this is the same thing as typing this. So if it is false, then we know that we can only go down. Otherwise, if we can't go down, that means that we can only go right. Otherwise, we can go right and down. So let's go ahead and see what happens in this case. If we can only go right, then we will. So if we can only go down, then we will return the new cost down. Because we can only go down, so this will be the solution. If we can only go right, then we will return the new cost right. And what if we can go right and we can go down? Then we will need to return the lower. Of course, we can do another if statement here. If one of them is lower, than the other, then we will return the lower one. Otherwise, we will return the other one because that's the lower or equal to the other one. So of course we can do this, and this is correct. But what makes your code more readable if you return the minimum value. So this function takes two numbers and returns the minimum of them. So input these two, and it will return the minimum of them. But you need to pay attention in this minimum and maximum function as well. If you have an integer and then you have a long integer, it doesn't actually work. You need to have them at the same type. So if, for example, if this is a normal integer, then you need to cast it to the long integer in order to return the correct value. Most of the times, it casts automatically between different types of integers, but in this function, you need to explicitly convert it. So in this case, both of them are long integers, so you can return to them the minimum of it. So now this code does work, but there is some problem with it. Let's go and enter it. And I will take the input from our drawing here. So we have a 3 by 3 table, and we have all of these numbers. So I will take the input from here. We have a 3 times 3 table, 0, 3, minus 2, 1, 10, 3, minus 10, 20, 11. And as you can see, first, it didn't output anything. Go ahead and copy the input so I don't have to write it by my hand again. So don't forget to actually output your answer that you want. So in this case, we need this answer variable to be outputted. So this is the first problem. So now it's 15. I can go on and try to solve this on our own too. So we obviously need to step onto 11 and to 0. So from the other roots, the lowest I can see is we go right, right, and down, down. This will be 3, 6, 4, and 15. And that's the lowest solution that we can get. So this solution seems to be correct. But what is the problem with our solution? It's due to our time limit. So let's take a look at this function. That's the maximum runtime, the maximum number of operations, if we call it from the 0, 0. Every time we enter here, we start 2 new function calls. When we go right and we go down. This means that every time we call this, we need to calculate 2 other solutions before we can return. So this is exponential. Every time by increasing the value by 1, our runtime doubles. So this will be huge number, and it works only for really small solutions, or only really small inputs. That means that we need to do something to decrease the value. And this is something called dynamic programming. So we will actually store the total cost of the n times n table. And we will also store a Boolean value of has been calculated. Remember, this is default for yes, always false for all of the all of its numbers. So when we go here, then before we return a value, we do the following. So now we already calculated the cost of the xy. So what we do is take this has been calculated xy, set it as true, meaning that we already calculated it, and we will store the value, this total cost will be this new cost. We will do the same thing every time before we return. Make sure to store the right value, the same that you return, and here. In the case of x is n minus 1 and y is n minus 1, it doesn't matter because we return immediately anyway, but we can actually store that value too if we want. Copy it from here. So, what does it change? Well, every time we calculate one of the values, we will store its value. And in the beginning of our function, we do a trick. If it has been already calculated, then we know its value. And it won't change because we don't change any of these numbers in the grid. So we can, without calling any other functions, return with the total cost. So what does this do with our runtime? So for every x and y, this function will be executed only once, meaning that our runtime is n times m times the function's runtime, which is really low, only the calls when we call the other cast function, but the calling other cast function will only be n times m. Because when we call the cast function and it's already been calculated, its runtime will be 1, just one operation. Has been calculated, yes, we return. So every time it has been calculated, its runtime is simply 1, and if it hasn't been calculated, it will only happen n times m times. Meaning that our runtime now is n times m around m times n. Obviously we do more operations, but these are just some operations, so it's just a constant. So we multiply it with a constant number, which we usually ignore. If your constant multiply is not really bad, then it doesn't really matter. So this is around 10 to the power of 6, which is pretty good in the inside of even 0.1 second time. So now this solution is correct for the A problem. So we can go ahead and run it. And even for larger numbers, it will work correctly. That's 212. Believe it, I didn't actually calculate the result for this one. So, storing these values as a total cost is called dynamic programming. And usually it's done differently than in a function. So, you can see this solution, you can copy it and do it like this. But I will show you another solution with dynamic programming. So we go ahead and delete this function. We start from another solution. So instead of the main function, we'll say that we will fill up the total cost. This total cost variable, we actually delete this has been calculated, we wanted this. So we go ahead and fill up everything about it. We want to know all of the total cost. So that means that the answer will be equal to total cost 0, 0 once we add them. You actually don't even need this answer variable. You can just output total cost 0, 0 if you already have it. I will keep this so you can see that this is actually the answer. And then we can output the answer. You can see that once again we haven't even done anything, but we already assigned the value to answer and output it. Now we need to solve the problem before we assign the value to the answer. So what do we know? First thing first, we know that the total cost of m minus 1 will be equal to the c m minus 1 m minus 1. Because when we are right there, we just add that number to our solution, that's it. So we know that. But we don't know the other sum. But what do we know if we know this? Well, if we know the solution here, then we know the solution here and here as well. Because this will be equal to this plus the solution here. So we know this. And we know that this will be this plus the solution here. And then what do we know? Then if we know these two, we will actually know this, this, and this as well. So for example, the solution here will be this plus the minimum of the solution here and the solution here. So all we need to do is go in an order that will make sure that every time we reach one of these numbers, we already know the solution there. So one way to do this, there are actually many ways that we can go, is that we will do nested loop once again. But in this example, we will go from n minus 1 and we will go until the I is at least 0. And instead of adding 1 to I, because then it will be an infinite loop, we always add 1, it's always larger than 0, we'll subtract 1. And then we will do the same thing for the j variable. So what will this do? We start here, then inside of this loop, we go here, then we go here, then we go here, 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 and here. And as you can see, the order we go, every time we reach a number, we already solved the solution to the number below it and the number direct to it. So we will be able to solve the problem from that number as well. So the total cost of ij will be equal to the cost of ij, because we step on it. If we are here, we step on it, then the minimum of total cost I plus 1 j, when we go right, and the total cost of I j plus 1. Once again, there is one more problem. We might not actually be able to go right or down. So this assumes that right now we can go right and down as well. So in order to fix this, we have this if statement. If I is n minus 1, then we can't go right anymore. So the total cost will be this, plus we will go down instead. If we can't go down anymore, then our total cost will be similar, but we will go right instead. And otherwise, it means that we can go right and we can go down as well. Then we put the word so you can see better, then we will have this total cost. There's one more thing that we need to think over. If I is n minus 1 and j is n minus 1, we'll actually go in this if statement, and we assume that we can go down. But that's not the case, because even though we can go right, we can't go down either. So what if we can go right and we can't go down either? Well, that means that we are right here. But we already assigned a value here. So we say that if we are at this position, this is end. So both of these statements has to be true here in order for the if statement to be true. If we are right here, then we will continue. Continue is an expression that makes you continue the next for loop. So if we are right here, we'll go ahead and continue this for loop at the next value, but for this iteration, we will skip all of these below. So you might actually not knew this because I haven't taught you this, so I will show you another solution here. So if this is true, then we just don't do anything, and we will go in these statements only if this was false. Or we can assign the total cost of this right here as well. I will go ahead and do the solution and we just continue. So in this case, we will have our total cost. We go ahead and run it and see our example input. Most of the programming competitions, by the way, provide you an example input and an example output where you can test your solution to see if it works correctly. So it's 15 as well as our other solution. So why is this good? Well, it's much simpler than this function that we wrote. The runtime won't be an issue because we can see that we go through these loops n times m. So it's much more simple and much harder to go through the time limit. And also, if we take a look for the P statement, we need the output of sequence of characters containing R entry that takes the minimum cost possible. So we can actually use this total cost to cleverly come up with a route. So right here we have all the total cost. We will have a string called path, and it will be empty. This is just assigning an empty string to it. Strings come with as empty, so you can just do this. I like to assign a value because if it's an integer or other types of variables, it might not have these default values, so it's better to assign a different value, just a good habit. So in this case, we will go to the while loop and we will store our current position as x and y, you can call it anything, and we will go by our position. It's not this, so by our position is not n minus 1, n minus 1, meaning that either x is not n minus 1 or y is not n minus 1. This is the not equal operator. Then we will go in our loop. And when we are done with our loop, we don't know what we are doing yet. I will just build the code in this order. We will output the path So what do we do here to get the path? Well, if x is minus 1, then path equals. So path equal means that we can add a string or a character to that string. So we will path equal down. So if x is minus 1, that we can't go down, we can't go right anymore, so we will go down. Similarly, if y is n minus 1, then we can only go right. Should go out and add these strings, not as characters, because we need to add a string. So not a string to see that if we write this, this is considered as a string. If you write this, this is considered as a character. So you want to append another strings. Reason for this is then you can actually append more characters to it. So this is just easier for us. So in this case, if x is m minus 1 and y is m minus 1, then we already go outside the loop, so we don't need to worry about that case. And otherwise, if we have both of the options, then what do we do? Well, we take the total cost of this plus the cost of that cell. So what we know about the timing problem is we either created this solution by going right or down. So this will be either equal to the total cost of x plus 1 y, or it will be equal to the total cost of x y minus y plus 1. Simply because of the reason of how we calculated these values. So if it's equal to this, then we will have the path be right. Otherwise, we have the path down. And also, don't forget to increase the value by 1. Y, x here, x if we go right, y if we go down. You can also put a debug here option here. So instead of simple else, we say that if this is equal to this, and if it was not equal either of them, then we will output that we haven't found the path, and then we will return 1. So returning in the main function is just a return value that you see at the end of the code. 0 is the correct return value, and you can just return 1, for example, if you have some error issues, so you can see from the return value and your error output. But this shouldn't happen ever, because none of them will be true. So if we go and build and run it, take our usual input, and we can see that we got this path not found error. So we can go, and this is why debug codes are really important, because then we know where the error is. So if you have something that a code that doesn't work, then you need to put this debug into it. Even if you are just writing a code and you see a good opportunity to write a debug code, then you can go ahead and write it there. So let's try to find the error. So I will show you the code So we know that the error is here, that the total cost xy plus the cxy is not equal to this total cost, and it's not equal to this total cost either. Okay? Let me show you how we generate the total cost. Okay. So, can you find the error? Go ahead, pause and think about it. Or I will show you the error. So, the error was actually that I wrote is plus cxy on the wrong side of the equation. Congratulations if you found it. So, we don't need to add to this xy, we need to add to this side. So we will put this here. Or we can subtract that from there, whichever works for you better. So let's try with the back terms. I wanted to show you is really important. Now that we have the correct solution, we can go ahead and run it. Like these values. By the way, if you have like larger inputs, it will be more comfortable to store them in a file, so you can just copy and paste them every time. Or you can actually use the file as input, but I will show you that on the video. So we will input this. So you can see that the solution is 15, and then we go down, down, right, right, which is this path, and it's not 50. The reason for this is that we haven't actually went with the good path. So we here, if x is n minus 1, the coordinate that goes to here, we say it's down. Otherwise we go and say it's right, and it's the opposite. And the other really important thing that I wanted to show you is that if you have a wrong solution, you need to figure out why. And in these two-dimensional cases, lots of times it's simply because you inverted the coordinate somewhere. So you need to check it. And here the problem will simply be is that if x is n minus 1, that actually means that we are down here, because x coordinate corresponds to the n value, and it will be down here, so we can only go right. And in the case where y is here, then we will in this case. So it will be flipped like in normal coordinate system. The x means that we are down, and the y means that we are right, which is counterintuitive, and it's really easy to forward. So we will swap these errors and these. Now it will work correctly if we go and put that on it. So as you can see, we have our path, and it's correct. And if you wonder, this works for larger inputs as well, because our runtime is n times m, which is 10 to the power of 6, so we have all the correct solutions. Hopefully you enjoyed today's video. If you did, make sure to like and subscribe, and see you in the next video.